Hi, in this video I'm looking at the scalar product of vectors. So we're talking about how do you multiply two vectors together to get a scalar answer. So the base definition of the scalar product of vectors is that if you've got a vector, vector A, and you've got a vector, vector B, and you know the angle between them, then the dot product, or the scalar product, it's called the dot product because we use the dot multiplication notation rather than the cross for multiply, just to be clear from the other vector product, the vector product, which is also known as the cross product. And it's the magnitude of your two vectors multiplied together, multiplied by the cosine of the angle between them. So if we look at an example, say, where we have two vectors, I've got, say, vector A, and the magnitude of A is 5. And I've got another vector somewhere, say, over here, vector B. So I'm going to try and draw it a little bit more accurately to my angle that I'm planning on putting in. Let's go vector B, and the magnitude of B is 6. And the angle between them is 60 degrees. What's the scalar product of these two vectors? So my scalar product, by my rule, is going to be A dot B, which is the magnitude of A times the magnitude of B, cos the angle between them. And so if I work this out, the magnitude of A is 5, and the magnitude of B is 6, and the cos of 60 degrees. And if you work this out by putting in a calculator or working it out, knowing the fact that cos of 60 is a half, then we find out that the answer is 15. So the scalar product between these two vectors is 15. So let's actually have a look at one where we have the actual vectors. So if I have the vectors, it gets slightly different, but we just put it into our rule. So what if I have the vector P, which is the polar vector 3, 40 degrees, and I have the vector Q, which is the polar vector 8, 125 degrees. So to do this one, I need to know what's the angle between these two. So let's draw the diagram of these vectors so that we can see what they look like. So on the Cartesian plane, P is the angle 40 degrees, so it's going to be something like that. So that's going to be vector P, which is magnitude 3 and angle 40 degrees. Q is the vector at 125 degrees. So 125 degrees is over here, slightly straighter than that wonky line. And its angle is 125 degrees from the positive x-axis. And it has magnitude 8. So if I want the angle in between the two, so if I want this angle in here, well, then that's going to give me 125 minus 40, because 40 gets me to here, 125 gets me all the way around, so the bit in between the two is the difference. And so that gives us an angle of 85 degrees. And so now I can go to our rule. The dot product between P and Q is the magnitude of P times the magnitude of Q cos the angle between them. Putting in our information, P has a magnitude of 3, Q has a magnitude of 8, so we have 3 times 8, and we then multiply by the cos of our angle between them, which we worked out to be 85 degrees. And so if we work this out, P dot Q, the scalar product of these two, is 2.0917, or 2.09. So that's our answer for those two. And what if we look at one that's in component form? So polar form is easy enough because we can draw our diagram and figure out how to get our angle between the two by which one do we subtract off. If we're in component form, life's easy but slightly different. So if I have the vector A, say, which is the component vector -1, 5, and I have the vector B, which is the component vector 3, 6, how do I find the scalar product between these two vectors? Well, there's another rule for if we have it in component form, and that rule is that if I want A dotted with B, the scalar product, I get the x component A1 of vector A and the x component B1 of vector B, and I multiply them, and I add on the product of the y components of the two, A2 and B2. So this is A1, and this is A2, and this is B1, and this is B2. A1 is the x part, A2 is the y part. B1 is the x part, B2 is the y part. So now I've just got to put these numbers, these four numbers, into this rule. So I've got A1, which is -1, multiplied by B1, which is 3, and add on A2, which is 5, multiplied by B2, which is 6. So in this case, our dot product is -3 plus 30, which is 27. So there we go. The scalar product of two vectors is the product of the magnitudes and the cosine of the angle between them. So if we know that information, we can apply the rule. If we have polar vectors, we just need to draw the diagram so we can figure out which one to subtract so we get the angle between them, and then apply our rule. And if we're in component form, we have this alternative rule, A1 B1 plus A2 B2, the product of the x's plus the product of the y's.